scenario, you're saving money for summer camp. You deposit $100 on the first of each month into your savings account. The account grows at a rate of 0.5% per month. How much money is in your account on the first day of the 10th month? Okay? So let's think about what's happening here. Okay? So for month 1, how much money goes into your account? $100, right? You put $100 on the first day. So you're just going to have $100. Okay? Now, for month 2, how am I going to figure out how much money is in there at month 2? So the first day of month 2 comes, Savannah? Yes. Good. So this 100 that was already in there is still going to stay in there. I'm actually going to write it right here. I'll show you guys why in a minute. And it's getting multiplied by 1.05, meaning we kept the whole thing. Oh, sorry, 0.05. Eraser. Okay. So it's getting multiplied by 1.005. Does everybody understand why? You heard Savannah kind of think out loud about it. It's a 0.5%. So there's the $100, and now it's whole self and this extra 0.5%. But what did it say you're doing on the first of every month? Penny? Depositing another 100. So not only is this full 100 sitting in there with this percentage of interest getting added to it, but now you're also going to have added another $100. Okay. I'm going to let you guys add this up in a minute when I let you work with your groups. Okay. So what's it going to look like for the 3rd month? What are you going to put into the account on the 3rd month? Michelle? Okay, so here's where it gets a little bit interesting. This 100 from the first month has now sat in there for how long? 2 months. So based on like the investigations that we did on Financial Week, that 100 was multiplied times 1.005 to what power? 2, because it sat there for 2 of the time periods that we've been looking at. But this 100 that was put in on the 2nd month, it's multiplied by 1.005, but that's only to the first power because it's only been sitting in the account for a month. Okay? So notice that the sum of the 3rd month is going to have the 100 you put in, the 100 from the previous month, so that puts the rate to the first power, the 100 from 2 months ago, so that's why that's to the 2nd power, and then you'll be able to continue that. So if you were going to write a rule, so I'm not asking you to add them up right now, but I'm just asking you to kind of review what you did before. If somebody wanted to find, okay, like the 10th term or the nth term in this geometric series, okay, what's the first term? So look at the way we've been writing out the series. The first term for each one of these is 100, okay? What's the rate at which things are growing? So I see Savannah's hand. She gave me 2. Somebody else. What's our rate? Michael? Good. 0.5%. And remember, we're keeping the whole 100 plus the 0.5%. So we're going to write that rate as 1.005. Okay? Because if we write just the 0.005, it will just take 0.5% of the 100 and won't include the whole thing. Okay? And this is going to be to the power of n minus 1. And now you can see why. Because when it's 1, do we actually have any interest rate going to any power? No. So we'd want the exponent to be 0 when somebody's plugging in a 1. When it's been in there for month 2, we have the 100, the first term, and then we have something to the first power, but not something to the 2nd power. So you can see that each time that last term is 1 power short. Okay? This only finds one specific term. Okay? Here, we're taking that term and adding the others to it because we're building a series and we want to find the sum. So here's what I want you guys to do. I want you to fill out this chart and actually find some of those sums so that we can verify them in a little bit. So this one's $100. That's good. We've already found that one. Okay? This one, you're going to do this arithmetic, and you're going to figure out what that's equal to. Here, you're going to do this arithmetic. You're going to figure out that that's equal to. You don't have to keep writing it out. Okay? And notice there are some shortcuts in how you could do this on the calculator. This sum is the same thing as the one before it, but with this extra term being added onto it, right? Okay? So you're going to do months 1 through 5, and then I want you to skip to month 10. However, if you have to put more things into the calculator, whatever you have to do. And then next to that, I want you to think about what this means in general, okay? In general, our rule is AN equals A1 times R to the n minus 1 power, okay? And here, the sum of month 1 is just the first term, but the sum of month 2 is the first term plus the second term, right? And the sum for month 3 is the first term plus the second term plus the third term, okay? So you're going to do some calculations on the calculator here to get actual totals, and this is just kind of telling people this means we're only adding the first term. So we're, again, used to the notation that we saw with sequences and series, okay? So take a couple minutes with your group and finish up this. Okay, who can tell me what they got for the sum of month 4? Samantha? Sum of month 5? Savannah? 505, 3 cents. Like that? Okay. All right, so take a look. Okay. I agree with them. If you guys agree with them. Okay. All right, so the 10th one was a pain in the butt, right? Because you had to do like 100 plus 100 times 1.005 to the first power plus 100 times 1.005 to the second power plus 100 times 1.005 to the third power. And you had to keep doing that till you got to the term that said 100 times 1.005 to the 9th power, right? Because our 10th term would have a power of 9 on it because 10 minus 1 in our formula. It's annoying, right? And you're doing something that has a pattern to it, so it seems like there's got to be a better way. Okay, so let's try to figure out. There is a better way. All right. So the first thing it says up there is just some information for you guys. So you guys know that AN is equal to A1 times R to the n minus 1. Okay? And so the way we wrote it in the chart is we wrote that the first term was A1. The second term was A1 plus A2. The third one was A1 plus A2 plus A3. If we want to explore this idea of patterns and see if there's a formula, we don't want to write out A1 plus A2 plus A3 plus A4. Those are different things every time. What we want to try to do is write everything in the term of as minimal amount of things as possible. So the way we can do that is we can use A1 and R, okay? Because A1 is just A1. A2 would be the same thing as A1 times R to the first power. A3 would be the same thing as A1 times R to the second power. What would A4 be? A1 times R to the third power. What would A12 be? A1 times R to the 11th power. At least then our entire thing is just dependent on A1 and R. Okay? So our sum that we were finding was A1 plus A2 plus A3 dot, dot, dot. We want to rewrite that using A1s and R's. So the first term would just be A1. Okay? Now the next term, instead of calling it A2, I'm going to write it as A1 times R to the first power. Okay? And then the next term would be A1 times R to the second power. And this pattern would continue. Now, if I was adding up n terms, then the last one would be A1 times R to what power? So the nth term, though, would have what power on R? The n minus 1 power. So it's going to look like that. Okay? And that would be how you would tell someone to add up n terms. This isn't much better, but it's a little bit better because everything just has to deal with A1 and R. Okay? So go ahead and take a second in your group, rewrite the same thing I just wrote, but on the right-hand side of the equation, factor out A1. Okay? So Sn equals, and I want you to write what the right side would look like if you factor out A1. Does that make sense? We factor out the A1, we have this. So if only there was a way to get this to be something better, right? So mathematicians figured out a way. You guys are going to try it right now. So what you're going to do for the next step is you're going to take what you have. And you're going to multiply both sides of the equation by 1 minus r. So this side's going to get multiplied by 1 minus r, and so is this side. Can I do whatever I want to an equation as long as I do it to both sides? Yes. Okay, so this is okay. And you're probably thinking, like, why? So let's figure out why. I want you guys to try and simplify the right side as much as possible. Okay? Focus on this part and see if you can see that this calculation actually does anything good for us. So take a couple minutes with your group and try to figure out, you need some scratch paper or something like that. What would multiplying something like this times 1 minus r do for us? Some people are telling me some things that are happening. What do you guys see happening when you multiply these two quantities together right here? So did you guys get some stuff that's canceling out? Okay, so let's think about this. Let's say I distribute, I'll do my scratch work over here. Let's say I distribute the 1 to every term inside of this parentheses. 1 times 1 is just going to be 1. 1 times r is just going to be r. 1 times r squared will be r squared. R cubed, right? This is going to continue. Just to make a point here, it's going to continue till r minus 1. What's the r to what power right before r to the n minus 1? What's 1 less than n minus 1? Minus 2. Okay? So it would look something like that if I multiplied the 1 through, right? Now let's say I went ahead and I multiplied through by the negative r. Okay? And now I distribute that, because that's what we do with distribution, right? We distribute 1 to every term in the set of parentheses, and then the next one. When I multiply through by negative r times 1 makes negative r to the first power. I'm going to line up my like terms, okay? Negative r times r makes negative r squared. Negative r times r squared makes negative r cubed. This is going to continue, okay? But what is going to be the last power of r that I reach? So when the r multiplies the r to the n minus 1 power, what power do you get then? So think about it. You're multiplying r to the n minus 1 times r to the first power. What do we do with exponents when we have the same base? Like, what is x to the third power times x to the second power? X to the fifth power. So this means r to this power times r to that power is r to the power of whatever they are when they're added together. Is r to the nth power, right? So this is all going to continue. Those of you that said you got stuff that canceled out, you're totally right. But it's going to have this extra little thing here at the end. Sorry, I'm running out of space. But minus r to the n. So everything's going to cancel out except for the 1 that we had at the beginning and the minus r to the n that we had at the end. Okay? So what we get here is we get that this side we didn't do anything to. We have 1 minus r times the sum equals a1. And we figured out that when all of these multiply those, we're left with 1 minus r to the n. A little simpler than adding up all those terms individually, right? So the last thing that we have to do is we need to put our sum back into the way we're used to looking at it. So you guys have it right now on your paper. I had to flip to a new slide. So it says to take both sides and divide by 1 minus r. Okay? So the only reason I'm doing that is to get the s alone. So I again have for somebody like this is the formula for sum. So the sum sits alone and all the work sits on the other side of the formula. So when I divide both sides by 1 minus r, that cancels over here. And it's part of my formula over here. Now 1 minus r does not cancel 1 minus r to the n. Okay, that's a different power of r. Those won't always be the same thing. You can't factor that right now. You don't know what n is and all these different things. So your formula is that you will find the sum by taking the first term, multiplying it by 1 minus r to the nth power, the n being the number of terms you're using, and then dividing it by 1 minus r. So a crazy formula, but there was a way they came up with it, was trying to get rid of all those terms with the same thought that you guys have when you were just trying to find the sum of 10 terms. Like, this is annoying. There's got to be a better way. And so mathematicians thought of a better way, and then that's how they came up with this generalized formula. Okay? So if our formula is correct, then we should be able to go to our previous problem, our little scenario. We had an answer. Let me go back a couple slides. We had an answer of $1,022.80 after month 10. So let's see if our sum formula gives us that answer. So we're going to see, is the sum of 10 months in this scenario equal to that? What was the first term of that sequence? 100, right? We're starting with 100. Times 1 minus, what's our ratio in that problem? Look at the rule that we wrote in the chart. 100 was the first term. What was the ratio? 1.005. Okay, the reason we had to use the 1 is because we were keeping the 100 every time. And now we're going to raise it to the power of 10 because we're trying to sum the first 10 terms. We're going to divide all by 1 minus 1.005. So go ahead and put that in your calculator. So you should get this. And if not, there's an error in the way that you're probably putting it into the calculator. So just a note about how to do that if you're struggling. When I put it in, I generally put it in like this. That's kind of how you see it. Probably the biggest thing that people forget here is to put parentheses around what you want in the denominator. If you just write divided by 1 minus 1.005 and you don't put it in parentheses, it divides this by 1, gets an answer, and then subtracts 1.005 from it, and that's not what you want. All right. So any questions about this? Okay, so we kind of reviewed our formula. We came up with a sum formula. Are we getting the right answer? People say yes, some people say no. So I'm going to come around and check some calculators. Look at what if our sequence or series is infinite. So skip a couple pages in your note guide. If you don't have the note guide, just continue the investigation where you are. Okay, so I basically want you guys to just fill in this chart. So little sigma notation here, so let's remember how this works, and I'll do some with you on the side. Okay. So in this first one right here, look at A. Okay, so you see the formula. So if we want to find the sum quickly, we want to use the formula that we just came up with, right? So how do I know that all of these are geometric sequences or series? What about the way that the rule is written tells me that they are geometric? If you don't know this, you won't be able to find the sum. Okay? Yes. Okay, there's going to be multiplying between term to term, and how do I know that by the way that the rule is written? Or? Good. The exponent is a power on some base, right? It tells me this guy that's being raised to the power, that's going to be my ratio, right? Because the first term is going to take this to some power. The next term is going to take it to another power, okay? All right, so even though it doesn't have like n minus 1 in the exponent, whatever, it's geometric, okay? And whatever's being raised to the power is going to be your ratio. So look at A. If I want to find the sum when n is equal to 5, in other words, I want to find the first 5 terms. Don't write out the first 5 terms. Think about your sum formula and what you need. I need the first term, I need the ratio and how many terms I'm adding together, and that's all. Okay? So in the first series, okay, looking at part A, what would be the first term? So look at the bottom of the sigma. It says the first term is when k equals 1. Plug 1 in for k. What's a half to the first power? A half, right? So my first term is going to be 1/2. Then I'm going to do 1 minus, what is the ratio in that problem? So we just talked about the way that the rule is written. Remember your geometric rule, A1 times R to the n minus 1. So these powers aren't n minus 1, but notice the ratio is whatever's being raised to the power. So what's going to be my ratio for part A? When you look at the side of the sigma notation and you look that it says 1/2 to the k power, what is the base of the power? What's being raised to a power? 1/2. Therefore, your ratio is going to be 1/2. Okay? So 1 minus, my ratio is 1/2. Now, to what power? Look at the top of the column. For the first problem, we want to find the sum when n is equal to 5. In other words, we want to find the sum of the first 5 terms. So they're specifically telling us we want to use when n is equal to 5 this first time. Okay, so we should put this in and get our sum. And why wouldn't what be 1 and 1/2? Because in this problem, if you wrote out a couple terms of the sequence, if you plug in 1 for k, you get 1/2. If you plug in 2 for k, you get 1/4. If you plug in 3 for k, you get 1/8. So notice they're just being multiplied by 1/2 every time. Okay? All right, so then you can plug this in and you can get your sum when n is equal to 5. Notice that the next column says find the sum when n is equal to 50. If you punch in this whole calculation in your calculator, do you guys remember that if you push second enter, it will bring back up everything you just typed in? Okay? So if you do that and you scroll over to here, okay, and you just say, I want to insert something before the parentheses, you can just change this exponent from 5 to 50, and now you can be finding the sum for the first 50 terms. Okay? What do you guys expect to happen as you find the sum for 5, then for 50, then for 500 terms, then for 5,000 terms, and then for 50,000 terms? What's going to happen? I see Lauren's hand, but she's answered a lot of my questions. What's going to happen when you add more terms together? So first you're adding 5 terms, then you're adding 50, then you're adding 500, then you're adding 5,000, then you're adding 50,000 terms together. You have to have some expectation. What do you think is going to happen? Okay, so it's going to increase because you're adding more stuff to it. Okay, Michelle? Okay, so you are adding new stuff, but the stuff you're adding is smaller, so maybe that has some effect on it.
You're never going to get like your entire sum because the numbers are just so small.
Okay, so he's saying you are adding things, but then because you are adding those small things, he's saying they are going to make them bigger, but maybe not anything necessarily. Okay, so it's going to very gradually increase for a little while. All right, so I'm going to let you guys figure it out. You're going to plug in these things. So you have enough information to do this for all of them, okay? What's the ratio here in F? Just so you guys don't do it wrong when you get to that point. What's the ratio? The rule's written there. The ratio is the number that's being raised to a power. I said this like 3 times. So look at the rule inside the sigma. What number is being raised to a power? -2, right? So the ratio is -2. If your ratio is negative, make sure that that negative, you guys, goes inside this parentheses of what's being raised to the power, right? The minus side is part of the formula. And don't say, oh, well, minus a negative equals a positive, so I just put a plus. That's not okay, because you don't know if this number is actually a negative or positive until you've done the exponent. So put everything in purely as it starts as one equation so you can see what happens. Okay, and I'll walk around and help those of you that need calculator help.